Okay, so on page 2, we need to look at solving these differential equations, and I think we remember how this works. I'm giving you the derivative. How do you find the original? You need to do the antiderivative. So in number 4, I'm going to say y equals the integral of 3 over 2 minus x dx. You're going to find your antiderivative. When you're done, what do you stick at the end? Plus c. And then the whole point of these differential equations is I gave you a little more information. You're going to use that to find your c value. I would like to see what you can do pretty much with this whole page. Don't go beyond page 2. But please talk with the people in your group, help each other out. And as you go, I'll start getting some of my work up on the screen as well. Again, as you're going, if you get stuck, take a look at the screen and take a look at what I've done so far.
Oh, we're already done.
Very good. I do want you to do the entire page too.
The entire page?
Don't be a pain. Problem? Okay. You have a skeptical look on your face. Okay, so I'm done with number 4. Take a look at my work. Your c value should have been 0. I hope. Maybe. Well, yes, you do need to do that.
Wait, what?
Okay, so I'm set with number 5. Take a look at my work for number 5 and see if my work and my answer agree with yours. Getting a negative 7/4 for my C. And number 6, it's a second derivative. You need to do 2 separate integrals because one needs a u substitution and one doesn't. And then you need to do it twice. I hope we're working. Group on the side that I hear a lot of non-math talking going on. And work. Uh-huh.
Now we're doing the integral of this one, and here is u. Oh, and
That was us in Chem class. Oh my gosh, yeah, we sounded so educated. No, I bring the empirical formula of this reaction, which is a no theorem.
Okay, enough out of you. When you're done, just sit quietly.
We're just having fun with calculus.
I am well aware. Okay, so I have my first derivative figured out in number 6. I have f prime of x equals negative cosine x plus 1/2 e to the 2x plus 1. Do I believe you? Should I believe you? U substitution, not chain rule. Anything on how I got my f prime? Well, then do it again. You can integrate the negative cosine x and the plus 1 together because neither of those needs a u substitution. Do the other part separately because the e to the 2x part will need a u substitution, although maybe you just sort of know what will happen with that. And I think if you do it properly, your c value should be a nice number.
It should be a very nice number,
Yeah, that counts as a number. Okay, so I'm getting f of x equals negative sine x plus 1/4 e to the 2x plus a constant.
Wait, is that E on the bottom?
That is not. I don't know. Did you find your c value?
Did you?
What is it? It should be 0. We're going to get 1/4 equals the negative sine of 0 plus 0 plus 1/4 e to the 0 plus c. Well, everything on the right side is 0 except that e to the 0 part. 1/4 equals 1/4 plus c. Your c is 0. So our answer should be f of x equals negative sine x plus 1/4 e to the 2x plus nothing. Are there questions? I'm not sure if you're just like not doing anything, if you're done and got my answer, if you're confused.
At the end of the day, life's business, so it doesn't really matter. We're all gonna die.
Okay, like one more moment and then we're gonna move on. Oh my gosh. Okay, please turn to the next page. We need to look at 2 area problems.
I agree.
One more moment. How do you find area under a curve?
Why the integral?
Well, what sort of integral? A definite integral. That's all you're doing in these 2 problems. You're going to do a definite integral. In the first one, though, how would you do that?
Break them up.
Either you can separate your fraction. I think that's probably the best way to do it. Use some algebra to rewrite it, and then we don't need to use substitution. There is another way. You could use long division. That's going to be a pain. And honestly, anytime we have that, we use some sort of division, and separating the fraction really counts as division as well. So rewrite it using some algebra or whatever, and then go do your integral. The second one, you'll need to use substitution at least on part of it. See what you can do on this page. Then we'll do a lot of the rest of this together.
No plus C. Definite integral.
And please give exact answers for your C values. So if there are natural logs or E's left, that's perfectly fine. Oh, and by the way, while you're doing this, you might want to have those strips out with the 2 graphs with those important values that you do need to be able to work with. The graph of the natural log of x, e to the x. So I'm set with number 7. I separated that fraction, then didn't need a u substitution to integrate x plus 4 over x. I integrated x squared over 2 plus the natural log of the absolute value of x, plugged in 4, minus plugged in 1. Realized the natural log of 1 was just 0, so that part goes away. And I didn't feel like doing 4 raised to the 4th, so it's fine to leave the 4 out front. Try 8, and then we will look at 9 together. And I hope we're working on number 8. Group on the side, but I still hear a lot of non-math.
I mean, technically math is all around us, so basically whatever you're talking about is in
Okay, hush.
I agree. It's close.
I wonder if you like are you Let's go. We're all not talking about it. Excuse me.
Thank you. So I'm set with number 8. I did this as 2 separate integrals. I integrated e to the negative 2x dx from 0 to 2. And then I integrated 2 from 0 to 2. When I did e to the negative 2x dx, that needed a u substitution. U is negative 2x, du is negative 2 dx. Sorry. Negative 2 inside, negative 1/2 outside. I changed the limits from 0 to 2 to 0 to negative 4. The other one didn't need a u substitution, just integrating that constant of 2. I integrated e to the u, got e to the u from 0 up to negative 4. Integrated 2 dx, got 2x from 0 up to 2. Plugged in negative 4 minus plugged in 0. Over here I plugged in 2 minus I plugged in 0. And then the rest is just some rewriting and simplifying with this. And we're going to take a look at the next problem together. Questions on any piece of this, because in the homework you will be doing some tangent lines, some area problems, some initial value problems. Or I can give you homework on something I haven't taught you. That could be fun.
Yeah. I'll pay you extra. I got 10 cents in my
Anything on this page? Okay, next page. Problem number 9. We are asked to find relative extrema and points of inflection of that function. Relative extrema, relative max, relative min, what do you need? I would like you in your group to find the first derivative, simplify it, and stop. I would like to do the number line work with you.
Me too.
But please do the derivative in your group.
All right, guys.
And I don't think you should be rewriting it. I think you should just leave it and use quotient rule. Okay, I've got a derivative. Natural log x minus 1, not inside the natural log, all over the natural log of x in parentheses squared. Can you please turn the desks around so you are facing the front, because you need to be able to see what we're about to do. So we need to find the critical values. Where do the critical values come from? What do you mean by that? Where the derivative equals 0, that's half of it. Or is undefined. So we set the numerator equal to 0, and we'll set the denominator equal to 0. Well, that's going to give us the natural log of x minus 1 equals 0. And that's going to give us, I can ignore the square and just say the natural log of x equals 0. Yeah, to solve an equation like this is what you did in that reading that night. We'll do e raised to both sides. We're going to get x equals 1. As for the other one, add 1. You're going to get the natural log of x equals 1. We'll do e raised to both sides. And we'll get a critical value of e. I'm undoing my natural log by doing e raised to both sides. Natural log of x equals 1, so e to the natural log of x plus e to the first. Well, e to the natural log of x is just x. E to the first is e. So I'm going to make a number line. Make sure you label your number line. This is y prime. I need a tick mark at 1. I need a tick mark at e, but actually there is something else I should include on here.
0.
Well, what's the natural log of 0?
1.
Use your graph. What's the natural log of 0?
1.
It's not.
2.
Look at the graph.
0.
You're not looking at the graph. What was that? It's undefined. What about the natural log of any negative number?
Undefined.
Undefined. So I need to put a little boundary on my number line at 0 so I don't plug in either 0 or anything less than 0, because you can't do that. The original function itself is not defined. I'd like to do the plugging in with you, and please have those graphs in front of you. It will help with this. Between 0 and 1, I'm going to plug in 1/2. What am I plugging into? Y or y prime? Y prime. I'm going to get y prime equals the natural log of 1/2 minus 1 over the natural log of 1/2 squared.
Can you just move
No, because it's not a power inside your natural log. I'm taking the answer and I'm squaring that.
Right.
Now, the good news is I don't actually care about the number for the answer, just is it positive or negative? Well, the natural log of a half. Look at your graph. That is something negative. Subtract 1 from that, it's even more negative. So your numerator over here is something negative. Exactly. I don't even care that the natural log of 1/2 is negative. When I square anything, I get positive. So really, when I do my plugging in, I can ignore the denominator. And my first region is going to be negative. Next, I need to plug in something between 1 and e.
2.
2 would be a good number. So I'm going to plug in 2. I'm going to get y prime equals the natural log of 2 minus 1 over the natural log of 2 squared. And again, I don't care about the denominator because of the square. It is always positive. Is the natural log of 2 positive or negative?
Positive, but it's less than 1.
Good. Natural log of 2 is positive. Positive minus 1. In general, I can't say, but I know the natural log of e is 1. So the natural log of 2 is something less than that. A little less than 1 minus 1 will make that numerator negative. So my second region is negative. I'm going to go and use x equals 3. I'm going to get y prime equals the natural log of 3 minus 1 over the natural log of 3 in parentheses squared. Denominator again is positive. Natural log of 3 is positive, but I guess what I really care about, is it greater than 1 or less than 1?
It's greater than 1.
Because I know natural log of e would be 1, so this is greater. So you're going to get a positive over a positive. That region is positive. Decreasing, decreasing, increasing.
Wow. I'd say a relative.
There is a relative min. Now I asked for coordinates, so we're going to say e comma
You have to plug that in.
to what? Do that and find your y coordinates. This was the easy part of this problem.
Oh, wow.
There's a reason I gave you a whole page
That's so cool.
for work. What's the y coordinate? E. You're going to get e over the natural log of e. Natural log of e is 1. So relative min at e, comma e. Next, we need to look at points of inflection, which means what?
Y double prime.
We need the second derivative. I would take this version of the first derivative. I would not do any rewriting. I would leave it as quotient rule. Find your derivative. And see if there's a little bit of simplifying you can do. But again, I'd like to do the number line work with you. Leave it as a fraction. Use the quotient rule. So low was the natural log of x squared. D high, the derivative of the natural log of x is 1 over x. Derivative minus 1 is 0. So that first piece is natural log of x squared times 1 over x. Next, minus high. Put that in parentheses, natural log of x minus 1. The derivative of the bottom is going to require the chain rule. So 2 ln x to the first times the derivative of the natural log of x, so times 1 over x. Draw the line, square below, over the natural log of x to the fourth. What could you factor out of the numerator? Natural log of x, anything else? And a 1 over x. Okay, so y double prime is going to equal 1 over x times the natural log of x. And I'm left with, well, a natural log of x from the first part and a natural log, 2 natural log of x minus 1 in parentheses from the second part. over the natural log of x to the fourth.
But we still got a fraction.
Okay, so what can you do?
Multiply by it. So we're gonna
Okay,
over x.
or can't we just move the x to the denominator because it's part of the
Good.
multiplication problem? What else could we do to simplify? You
Take the rate.
cancel out, did you say an x?
A natural log. Yeah.
I didn't hear the natural log part. Yes, cancel out a natural log of x, and you're going to get, I might as well clean up the top as well while I'm at it. We're going to get 2 minus the natural log of x over x times the natural log of x cubed. So again, I distributed my negative 2 inside the brackets that I had. I got natural log of x minus 2 ln x plus 2. Combine those natural log of x minus 2 ln x is negative the natural log of x with that plus 2 at the end.
Say, how many questions like this are on a quiz?
I don't know. I haven't written things yet.
Awesome.
I would like you to set the numerator and denominator equal to 0 and then stop after that. Again, we'll do the plugging in together. Set 2 minus ln x equal to 0. Set the denominator, although that shouldn't be too terrible, the denominator. I'm getting 0, 1, and e squared. I'm going to make a number line. 0 is still a boundary. I have 1. I have e squared. I'm going to label this as y double prime. I'm going to plug in 1/2. I'm plugging in now to my second derivative. I'm going to get 2 minus the natural log of 1/2 over 1/2 times the natural log of 1/2 cubed. Can I just ignore the denominator like before and just say it's always positive? No, the cube makes it not that. Okay. What is the natural log of 1/2?
Negative.
Something negative. So 2 minus something negative will give you something positive up top. 1/2 is certainly positive, but natural log of 1/2 is negative. A negative cubed will be negative.
Wow.
That region will be negative. As for the next region, there is a really good number to plug in between 1 and e squared, which is maybe not obvious. E would actually be a lot nicer to plug in than 2 or 3 or something like that. I'm going to plug in e. Actually, you take a moment and plug that in and see what happens. 2 minus the natural log of e over e times the natural log of e cubed.
Can you clap twice after each problem? Next problem.
Yeah, I think that was really important to keep people engaged.
Also, don't forget to subscribe to YouTube. Yeah. Was there?
What is the sign? What is it? What are we getting when you plug in e? I think positive. Natural log of e is 1. So the top is 2 minus 1, or just 1. E is certainly positive. Natural log of e is 1 cubed. It's still 1. So 1 over e. That's positive. After e squared, you could plug in like 10 or something like that. It may actually be easiest to plug in e cubed because we can do natural logs of those things. So I think that's what I'm going to do for my last test point. I'm going to plug in e cubed. What is the natural log of e cubed? 3 natural log of e. What's the natural log of e?
1.
1. So this is really just 2 minus 3. That's why I chose e cubed. 2 minus 3, just negative 1. Natural log of e cubed, again, is 3. Cubed is, well, something positive times e cubed is still something positive. It's going to be negative. So it looks like there are 2 points of inflection. Find your y-coordinates. Let's finish this. I promise the next one is less painful. It is. I promise. I've already done that problem.
Oh, that ain't a number. That ain't a number.
E squared comma e squared over 2 and 1 comma. It doesn't work. You actually don't have a point of inflection there. It would actually be an asymptote because the original function's denominator would have equaled 0 there. So only 1 point of inflection, even though it seemed like there should have been 2. E squared comma e squared over 2. Excuse me. I'd like to be able to hear this. One more time, David. Well, because the natural log of 1 is 0. 1 over 0, you can't do that. Undefined. Number 10 is a similar, okay, we're not clapping. Number 10, similar thing, relative extreme of points of inflection. I would like you to find your first derivative, and then I'd like you to factor out the GCF, which will make it a lot nicer to work with. We'll do the number line together. What can we do to this? Take out what? E to the negative x. Okay. We are going to get e to the negative x times negative x plus 1. And I think one of the critical values should be very easy to find.
I agree.
From negative x plus 1, you're going to get x equals 1. Now, we're listening in the back, right?
Absolutely. Always. Absolutely.
I'm going to set e to the negative x equal to 0. What undoes an e raised to something? Natural log. So I'm going to take the natural log of both sides. Natural log of e to the negative x equals the natural log of 0. So negative x equals, what's the natural log of 0? Undefined. You can't do the natural log of 0. What this means is you don't get any critical values from there. We only have one critical value. Just one.
Yay!
And it's even better than that. I'm going to do my number line. First of all, am I allowed to plug anything into e to the negative x? Or are there some values I can't plug in, like in the last problem with the natural log thing? Look at the graph of e to the x. Can I plug anything into e to the x? Regular e to the x? Sure, I think your domain is all real numbers. Well, a negative inside just flips that graph over the y-axis, but doesn't change the domain. So we're allowed to plug in anything. So I don't have any boundaries or anything. But plug any number into e to the negative x, and what happens? What sort of a number do you get? Positive. Isn't e to the x itself always above the x-axis? And if we put a negative inside there, it would just flip it again over the y-axis, but it's still above the x-axis. This thing's always going to be positive.
Wow.
So, really, when I plug in, I just have to really test the negative x plus 1 part. Plug in 2. Is this thing positive or negative? Negative. Negative 2 plus 1. And again, this thing up front is always positive. So that region is negative. Plug in 0. This is positive. This is, again, always positive.
Oh my God.
we have a relative max. At 1, comma, well, plug into the original. I'm thinking 1 comma 1 over e. I would like to see if you, with your group, can deal with your second derivative. I think when you do this, you should find the second derivative of this version, using product rule and chain rule and stuff, then factor out the GCF. It will be very nice like the first derivative if you handle this properly. While you're working on this, I'm going to come around and pass out the homework, which is not the packet we've been doing. Those were our notes. You'll get a similar packet for homework. And also the chapter review, which is due on Friday. So homework's coming up. Thank you.
Oh, wait. Oh, this for all. I thought this was a massive ass packet.
We're working. Again, it should work out nicely.
Are
like
you
the
recording
first
right now?
derivative.
Wait, I didn't.
You tell me that. You should be able to factor some stuff out. It should be good. We're going with the second derivative, I hope. And chapter review is coming out now.
Like, how many trees?
I'd like you to do the problem that I asked you.
Oh, you should. The trees, Mr. Wixon, think of them.
Yes.
It'll be 9 through 20 the next Hello? That's okay. Yep. Yes. When the bell rings, Jan and Aaron, they need to see you quickly in the office. I think it's about MCAS, if you haven't already been told. Go talk to the office when the bell rings. Okay. My second derivative. F double prime of x equals first negative x times derivative of the second e to the negative x times negative 1 plus second e to the negative x times derivative of the first is negative 1. Then plus the derivative of e to the negative x is e to the negative x times negative 1. This will give you x e to the negative x minus e to the negative x minus another e to the negative x.
Oh, what can we factor
Or x, hold on, e to the negative x minus 2e to the negative x. And you can factor out your e to the negative x and get e to the negative x times x minus 2.
And it looks like some very easy values you can get from that.
The rest of the work is similar to the first part. We will finish this tomorrow. A couple things. We have a quiz tomorrow that if you are not here, must be done by the end of the day Thursday. We are finished.